In this lesson, we're going to learn about the binomial series. To start, we are going to do the definition of the binomial series by finding the Maclaurin series of the function y equals 2, 1 plus x to the power of b. To start, let's remind ourselves what the Maclaurin expansion is going to be. We are going to have to evaluate the function at 0 and then add the first derivative evaluated at 0 times x plus the second derivative evaluated at 0 divided by 2 factorial times x power 2 plus the third derivative evaluated in 0 divided by 3 factorial times x to the power of 3 plus etc. So the first thing that we have to do is to evaluate the function at 0. So this is going to be f of x. So f of 0 is 1 plus 0 to the power of b. That is 1 to the power of b, and 1 to any power is equal to 1. Now let's do the first derivative. Now the first derivative of this function, we have to use chain rule, and the derivative is going to be p times 1 plus x to the power of p minus 1 times the derivative of the inside, which is 1 plus x, and that is just 1. So the first derivative is simply p1 plus x p minus 1. At 0, f dash of 0 is equal to p times 1 plus 0 to the power of p minus 1, and that is simply p. Now the second derivative is going to be p times p minus 1 times 1 plus x to the power of p minus 2 times 1. That is p minus 1, 1 plus x to the power of p minus 2. At 0, the second derivative is equal to p times p minus 1. Now the third derivative really quickly. Now we can use these values of the three derivatives to substitute in the expansion of 1 plus x to the power of p as f of 0 is 1 plus f dash of 0 is p times x plus the second derivative was p minus 1 divided by 2 factorial times x squared plus the third derivative was p minus 1 p minus 2 divided by 3 factorial x power 3 and so on. Now we want to write this in a more general way. We can do that if we say 1 plus x to the power of p is the sum from r equals to 0 to infinity, where r is directly associated to the power of x. So we start with power of 0, 1, 2, 3, and so on. So r begins in 0. And the coefficient is p minus 1, p minus 1, p minus 2. So that gives an indication that maybe there was a factorial in the numerator, p factorial, that somehow got cancelled. Now in the denominator, I can see there's a 3 factorial, 2 factorial, there's also a 1 factorial, and there's also a 0 factorial. And so I should have an r factorial somewhere in the denominator, but that's not the one that is simplifying the numerator. The one that is simplifying the numerator is, let's look at this. The coefficient of the second term is simply p, which means p minus 1 factorial was cancelled. The third coefficient, p minus 2 factorial, was cancelled. In the fourth coefficient, p minus 3 factorial was cancelled. That means we need to divide by p minus r factorial. And now the powers of x go according to r. We can write this in a different way if you remember that this coefficient is representing a combination, or a value of a binomial coefficient. So I can write this sum as the sum from r equals 0 to infinity of the combination of p and r x to the power of r. This is what we call the binomial series. Now this binomial series is going to be truly helpful when we have expressions of the form 1 plus x to the power of p. However, when we have a negative exponent, we do need to be a little bit more careful, and the definition of the binomial series that we should use is the expanded form instead of the compact form. So in the case of the first example, we need to find the binomial expansion of the function y equals 1 over 1 plus x to the power of 2. That is equivalent to saying 1 plus x to the power of minus 2. So in this case, instead of using the compact form, we should use the expanded form because the combination is not defined for negative numbers. So the expansion of 1 plus x to the power of minus 2 should be 1 plus minus 2x plus minus 2 times minus 3 over 2 factorial x squared plus minus 2 times minus 3 times minus 4 times x power 3 divided by 3 factorial plus so on. So simplifying that, 1 minus 2x plus 3x squared minus 4x power 3, and this goes on, and our final answer is going to be 1 plus x to the power of minus 2 is equal to the sum from r equals 0 to infinity of r plus 1 times minus 1 to the power of r x to the power of r. Let's do a final example. Find the series expansion of y equals 1 over the square root of 2 plus x. So before we can apply the binomial series to this function, we should write it in the form 1 plus x to the power of p. So for that, I'm going to write y in the form 1 over 2 plus x to the power of 1 half, which can be written as 2 plus x to the power of minus 1 half. Now I want to take the 2 out as common factor, so that's going to be 2 to the power of minus 1 half, common factor of 1 plus x divided by 2 to the power of minus 1 half. So in this case, instead of x, I need to write x divided by 2, and p is going to take the value of 1 half. So I can just write this as this is going to be 1 over root 2, the expansion of 1 plus x over 2 to the power of minus 1 half. So the expansion of this function is going to be 1 plus minus 1 half x over 2 plus minus 1 half minus 3 halves over 2 factorial x over 2 squared plus minus 1 half minus 3 halves minus 5 halves over 3 factorial x over 2 power 3, and so on. Now let's try to simplify this. So this will be the final answer.